Hi, this is Lakshmikant Tiwari. In this lesson, I am going to show you how you can predict household power consumption using RNN and LSTM. So you can download a dataset from this link. That link is here, individual household electric power consumption dataset from UCI machine learning repository. And this repository contains total 9 attributes, but there are the 7 attributes are important, but we have interest only in global active power attribute. And this data have total more than the 2 million the data points, and it is the meter reading for every minutes between 2006 to 2010 of a household in a United States of the America. All right. So in this lesson, basically I'll first start giving you introduction why household power consumption prediction is required, and after that I'll be showing you some data analysis. I mean how you can load the data and then how you can understand your data. Once you understand your data and feel missing values, after that we will be talking about exploratory data analysis, in which I'll be doing a lot of the plots, and then I'll be making you understand that what are the meanings of these plots. And once we are done with exploratory data analysis, then we will be working with the active power usage prediction techniques, in which we will first find out what is the problem, and then we will first frame a problem in which we will try to predict a power consumptions of coming week based on a data of a previous week. And after that I'll show you how you can build a very simple LSTM model, and then how you can evaluate your model. And in the final stage you will see that the total root mean square error is less than the standard deviation of your data, which is, you can say, that a good model. All right. Before we start this lesson, you can go ahead at my channel KGP Talkie. You can watch previous videos. There are so many videos based on deep learning, neural networks, and the Pythons and classical machine learning. And here are feature selections and the Python plotting, etc. So please do not miss those videos. You can go ahead and watch, and the link for this working file will be given into a video description. You can download this file from a GitHub. All right, so without wasting your time, let's go ahead and start this brand new lesson. All right, power outage accidents causes a huge economic loss to a country, and therefore it becomes very important to predict power consumptions in advance. What happens when a power outage occurs? A whole city goes into a darkness. Our household goes into a darkness. Our day-to-day work and study and industrial works, etc., get affected because of the power outage. So what happens? Suppose that if there is a huge power supply demand and grid or a power station is not able to supply that much of the amount of power, then it goes to dark. I mean, grid failure occurs. Once grid failure occurs, a power outage accident occurs, and in that case whole city goes into a darkness. So in some way, if we can predict a power consumptions for a coming days or coming week or coming month, and accordingly power supply companies can make arrangements or can repair power grid to supply that much of the power requirement. So in this lesson we will be basically predicting a power consumptions for a coming week. So a data will be given for a previous week, and then we will be predicting a power consumptions for a coming week. All right. So what happens actually, given the rise of these smart electricity meters and wide adoption of electricity generation technology like solar panels, there is wealth of electricity usage data available, and we will be utilizing the data available at UCI uci.edu, and there you can see this data set is available there, and this data set total have around 2 millions of a sample, and it is collected over a 4 year, and it has total 9 attributes, and in those 9 attributes it has date and the time. So if we remove date and the time, we get these 7 attributes, which is really very important. So our task is to detect a global active power. Our task is to predict a global active power. All right, perfect. So these are the 7 variables which are actually given in the dataset. You can download this dataset on this given link. Once you download this dataset, once you extract this dataset, you will get a .txt file, household power consumption.txt file. All right, and then after some cleaning, we will also save this another file, but after some work. So let's go ahead and assume that you have this household power consumption.txt file. And now we are ready to get started with our household power consumption prediction using RNN and LSTM. And to start working with RNN and LSTM, we need to first import some supporting libraries or Python packages like NumPy as NP, Pandas as a PD, matplotlib.pyplot as a PLT, and NumPy as and also NAN from a NumPy as well. So let's go ahead and run this. And once it is done, then we will be also needing a sequential layer and LSTM and dense layer as well. Along with, we will be also needing a dropout layer. I don't think we need a dropout, so let's go ahead work with without dropout. And after this we will be needing mean square error to evaluate the error, and min max scalar to bring bring our attributes in between 0 and 1, because neural network performs better if input variables are having values in between 0 and 1, or less than 1, or -1 and +1 kind of. All right, so let's go ahead and run this as well. Now after this, we are going to read this data. All right, so if you see this .txt file, this is quite large txt file, 133 MB, and you will see here it has date and the time format, and there is a separator, a semicolon separator. So what we are going to do, we are going to read this with pandas read CSV. There we can say like data is equal to pd dot read underscore CSV, and then we can give there the name that is the household power consumption.txt. And now if you press shift and the double tab, you will get here a separator. By default separator is comma, but here we need a semicolon. So we are going to provide separator, that is sep, a semicolon. All right, and since this is having also dates and the time, that means we also need parse dates is equal to the true. Okay, so there we have parse dates is equal to true. And after this, since this is kind of a large file, we are going to make low memory is equal to false. And after this, we are going to just run this cell. So once we will run this cell, it has parsed the it has read the data into the data. Now you can see it here in the data. It has date, time, global active power, etc. and etc. So now what we are going to do here, we are going to set this date as an index. And to do that, what we can do, the data dot set index. All right, and inside this data dot set index, the date time we can do, but before that what we need to do actually, we need to concatenate these two date and the times together. All right, otherwise one more thing what we can do here, we can also set here index column as well. If you if you press here shift and the tab, shift and the tab, you will see here there is index call. All right, so that we can set here index call is equal to date. So in this way, this index will be set for a date. All right, although we do not need, because we are going to set this date and the time together. All right, so let's go ahead and delete this since it is taking a little time. So what we are going to do, we are going to just interrupt this cell and we are going to just run it simply. All right, perfect. So the first of all, before setting an index, we need to concatenate these two columns together, date and time together. So what we are going to do here, we are going to say here data date time is equal to data, and then here we have date, then dot str. All right, so dot cat. Now we are going to concatenate this time column. All right, so str dot cat, then dot data dot time, then after that the separator which we are going to keep in between date and time, that is going to be a space separator. All right, so after this, if we see here data dot head, now you will see here a extra date and time column together. Now we don't need this data and the time. What we can do, we can just drop this data and time. All right, to do that, what we can do, the data dot drop, and in that we can drop this date as well as this time, and then we can set here in place is equal to true. That's mean it will just drop and then replace new values into the data itself. All right, it says that there is error because I have not set the axis, because I want to tell this line that drop date and time from axis 1, which is this one. Okay, now we have the data without date and time, but date and time is concatenated together in this new cell, that is date and time. All right, so after this, what we are going to do, we are going to make this date and time as an index. So to do that, what we can do, the data dot set index. All right, data dot set index, which is date underscore time. Okay, we need actually this set index, and then we can say that in place is equal to true, data dot head. All right, so we have got our date and time as an index. Now after this, if we see this the data.csv file, you will find that there are a lot of missing data. Let me show you those missing data. Yeah, you see here there are so many missing data, and those missing data are replaced with a question mark. Now our task is to replace this question mark with some value, and before replacing the some values, we are going to just replace this question mark with nan. Okay, that is not a number. All right, so to do that, what we can say here, a data dot replace, and inside that a question mark will be replaced with nan, and here I'm gonna say that in place is equal to true. All right, so data now has been replaced with nan, I mean the question mark has been replaced with nan. Now after this, let's go ahead and check how many values are there nan. All right, so that we can do here, np dot is nan a data, then dot sum. So with this we can say here, but before that we need to actually cast this string into a float, because if you see this data dot info, this is kind of object. That's mean these values are a string. We need to convert these values into a float first. Okay, so let's go ahead and first convert those values into a float. Data is equal to data dot as type. So this as type converts this into a float. All right, Now once this is converted into float, you will see these values has been converted into float. Now we can check this. Yeah, so there are 25,979 values are Yannian. All right, so we need to now replace these Yannian values with some particular number, and those are actually what we are going to do. We are going to replace these Yannian values with the same value of a previous year for a same day. I mean, let's say if power consumptions is X kilowatt on today's date, today is 9th of October, then I am going to replace that value with 9th of October of 2018. I mean for a previous value. So I'm just going to write a function for here for replacing. Okay, so field missing, and there I'm going to pass here a data. All right, so here in one day, what is happening here actually? Not in fact one day, but I'm going to replace those from a previous day, in fact. Okay, so here for one day, what we have, one day is equal to 24 cross 60 minutes. And one more thing you need to notice here, that the data which is given here, electricity consumptions here, you see, this is for each minutes. All right, so if you see here, the first day of the record is 16th of December 2006 at 5:24, and then 5:25 and 5:26. So this record is given for each minutes. All right, perfect. So in one day there are 24 into 60 minutes. Then what I'm going to do here, I'm going to just create a two for loop for row and the column. So for row in range of, so this data dot shape 0, that is row, and then for call in range, that's the data shape 1. All right, so here we have rows and the column. Now I'm gonna say here, if Yannian, actually if np dot is Yannian, that is the data first row and then column. If this is Yannian, then I'm going to replace it with the previous values of a previous day, so that I can say there data. All right, so row and then call is equal to data, and now you see here this row is representing a value of a particular day of a particular minute. All right, so if I want to fill from a previous day, I need to just subtract by 24 into 60. All right, so from a row, there we have row minus one day and then column. All right, so with this I'm just gonna call this field missing, and there I'm gonna pass here a data dot values. All right, so once this is passed, it will take a little time to complete its filling, and once it is done, then we can again check how many Yannian values are there. We can just copy and paste it here. All right, so let's go ahead and check. Now it is saying that there is no none values present into a data. So successfully we have replaced our question mark or Yannian with the values of a previous day. All right, now we have our perfect data. Let's go ahead and see the information of data. So here, and similarly, let's go ahead and get the description of this data, data.describe. It says that the minimum is here and there is maximum, standard deviation, etc., etc. These values are there. And then let's go ahead and see a shape of this data. This says that there are more than 2 million of samples and with 7 columns, and these 7 columns are attributes, or you can say a feature. All right, so now the one questions you might see here, if we see the head of this data, this is not this is not parsed into a date time format. So we need to first parse this into a date time format, and since we are going to predict the power consumptions for each day, that means we don't need data of actually for each minutes of a day. So what we are going to do, we are going to sum a data for each minutes for a particular day, and then we can say that this is total power consumptions for a particular day. For example, if we can sum a data for a whole day for each minute, then we can say that this is a total power consumptions for that day. All right. So let's go ahead and say here, prepare power consumption for each day. All right. Perfect. So now what we need to do here, we actually need to parse this date time into into actually date formats into pandas. But one more thing, you see here, this is a clean data. So what I'm going to do, I am going to store this new file. Okay, so that I can say here data dot to CSV, and there I'm gonna say that a clean I can just say that the clean data dot CSV. All right. So this clean data dot CSV is written there. Just wait for a few minutes. You will see here this clean data dot CSV. We actually don't need this. Just go ahead and delete this. Yeah. So this clean data dot CSV, it might take a little time to complete its write. Yeah, it's written. Now you see it is 113 MB. All right. So once it is written this clean data dot CSV, let's go ahead and read this data. But this time we will be reading this index we'll be reading that index as a date time format. You see here. Now this time we are, just wait for a few seconds. Yeah. Now we are going to read this date time, which is you see here. Okay. We are going to read this into a date time format. All right, so let's go ahead and read this into a data set is equal to pd dot read CSV, and there we have cleaned data dot CSV, and then here I'm gonna say that parse date. All right, so parse dates is equal to true, and then here I'm gonna say that index call, that is the index column. Index column, I'm going to say that is date time, and apart from that, here a low memory would be false because it is going to use a huge memory. So it will take a little time to complete this the data load. It might take a few minutes because it has 2 million the samples. So let's go ahead and wait for some time to complete its data parsing and data read into a new data variable data set. All right, so it took some time to complete its data load. Let's go ahead and see data set of few line of a data set. Now the first 5 line, it says that we have completely parsed data dates and time. So this is correct date and time, and it is parsed correctly. Now this is time to do exploratory data analysis. Let's do EDA, that is exploratory data analysis. In exploratory data analysis, what I am going to do actually, I am going to plot these active power, global reactive power, voltage, global intensity and submetering for each of the year. And as you know, this data is available from 16th of December 2006 to you can say the last few numbers, few lines with the tail, that is the 20 yeah, it's 26 November 2010. All right, so here we have a head and the tail. Now what we are going to do first, we are going to combine the data for a whole day instead of just a minute, and that we can do with the data is equal to the data set dot resample. All right, so the resample capital D, actually this is kind of daytime operation on a pandas data frame. If we say the D, that means it will resample according to this index in the form of the day. All right, and then we are going to apply here another attribute, that is sum. So what this function will do on this data set, it will sum these all the these attributes values for a particular day instead of each minutes. All right, so once it is done, then you can say here, you can see here a few lines of this data for a particular day. Now instead of the data available for each minutes, we have a data available for each day. All right, and here it is a sum of these data for a particular day. All right, perfect. So this is the sum for particular day. Now after this, what we are going to do, we are going to plot this data for each year. I mean for full year, these features we are going to plot. So I have already written the code for that. I'll explain you that code. Let me copy and paste that code here. So you see here, this line, the first line is creating a canvas of a figure size 18 cross 18, and then here I am iterating through the columns. So the very first column is global active power, and then the second column global reactive power, and so on. So this for I in range length of the data dot column. So I am iterating through the columns, and then here I am subplotting, the subplotting length of this data dot column. That means it is 7 cross 1. That means there are going to be a 7 rows in a plot, and then there is just a single column, and then this I plus 1 is going to set the plot number, and then with this name I'm going to get the name of feature which I'm going to plot, and then this data and the name I'm going to get the particular data with the feature name, and this is the title, and this is y tick is going to be a empty. All right, so let's go ahead and run this. So once I run this, you will see here, so there are 7 rows here, and in the 7 rows this is the first, second, third, etc. All right, and here we can set also log is equal to right, sorry, yeah, so you see here now it has set here at the right. All right, so with this now you see instead of right, can I set the right top or top right? I think it's top right. Let me see. No, it's not top right. Is it top? No, there is just right location. All right, so let's go ahead, just go ahead with the right. Now you see here the first one is global active power, and then here we have a global reactive power, and then voltage, etc. Now you see here there are some fluctuations as well. These fluctuations can be because of the power outage. I mean there is no power, so there is no voltage and there is no power consumptions in the house, and the meter reading is also kind of 0 for those particular days. And apart from that, if you see here, there is some particular similarity. It's kind of in between somewhere September or August, month of September and August of the 2008. All right, and you see here a similar power outage here also. This means this could be a power outage or there is no electricity consumptions for that particular house because of the people might have gone on the holidays. All right, so this is how we can see this. Now let's go ahead, since we are more interested into global reactive power. global active power. We will be predicting the power consumptions of this active power, and we will be using also this data. So let's go ahead and plot this global active power for each year instead of full year. I mean, we are not interested here in these other features, but we are just interested into global active power. So let's go ahead and plot this for all the 4 years. The 4 years means 2007, 8, 9 and the 10. All right, so let's go ahead and exploring active power consumption for each year. All right. Since the first year 2006, that is the December, and the last year is somewhere the mid of the November of 2010. So what we are going to do, we are going to just discard the data of just a few months or few days of 2006. So I'm going to plot up data. I'm going to plot the data of 2007, 8, 9 and the 10 separately. So for that, I am going to just say here years is equal to 2007, and then here we have 2008, and then here we have year 2009, and then here we have year 2010. All right, perfect. Now you see here there are for each month. So what we will be doing here, we will be plotting the data for each month. And if you see in the in this, we have here year and then the month and then days. All right, perfect. So I have already written a code for this as well, plotting active power for each month for a particular year. So for that, what I'm going to do, as I had explained you earlier, so this is just setting a canvas size of 18 cross 18. And now instead of in the previous plot, I had gone through each of these features, but now here I will go through each of these years, and those years are 2007, 8, 9 and 10. All right. And once we go through each of these years, then I'm gonna get here axis for subplot, because for this axis I don't think we need this axis, so we can just delete that axis. We don't need. And once it is done, then as we did in the previous, here there is going to be a 4 rows and 1 column, and then I'll be selecting a 1 subplot, okay, at a time. And with this active power for particular year, the data str year, okay. And since this since it is passed, this date time is passed into a particular year, so it will get all the data for those particular year. All right, for 2006 or 2007, 2008, 2009 and 2010. All right, I mean, you can verify that something like this. If I say here 2006, then you will see all the data which belongs to 2006. All right, and if I say here 2007, you will get all the data that belongs to 2007, and you see here there are 365 days in that particular year. All right, perfect. And then it is plotting that data, and here it is setting a title. So let's go ahead and see this. Yeah. Now by seeing this plot, you can notice one thing here. The power consumptions at the starting of the year and at the end of the year is higher than in the middle of the year, because this data is in US. So the people might have been using heating system during the winter season. That is why the power consumption is more in a winter season, and the winter season is somewhere starts from the November to March. All right, and after that you see from April to around the September, the consumption is less for each of the year. even in 2007, 2008, 2009 and 2010 as well. All right, so with this data exploratory analysis we can gain a lot of the information, like when people are tend to consume more power, like in a winter, and less power into a summer. And apart from that, there you can see here there is also a lot of the fluctuation during a month as well. That can be because of the weekly fluctuation, and in the household generally people work in the weekdays, so the power consumption could be less in the weekdays. But in the weekend, especially on the Saturday and the Sunday, some people tend to invest more time, or they actually give more time at the home, so they use heating and the cooling system more. But this is not always true. Sometimes people also go to the holidays and somewhere else on the weekend, so that the power consumption could be less. All right, so this is how we have seen this distribution year by year of this active power consumption. All right, perfect. Now let's go ahead and see this distribution, power consumption distribution, in the form of the histogram. Okay, perfect. Distribution with histogram. All right, so in a histogram, what I'm going to do here, I'm going to plot a histogram for each of these year. So simply what I can do, I can just simply copy this code and I can paste it here, but instead of that plt.plot, I need to just convert that into a histogram. All right, so here I can just say a hist. All right, and in the hist I can say that bins is equal to 200. All right, perfect. Now you see here, so here you see the power for each of these year. Now you see the power for each of these year is moreover it is concentrated around 1.3 or 1.5 here you see, but in the 2008 the power consumption is concentrated in around somewhere 1.5 or 1.6, but again in 2009 the power consumption is around 1.3 or 1.4, or you can say it is 1.5 kilowatt. And then similarly in 2008 the power consumption is somewhere around 1.5 kilowatt. So this is how we have seen a power consumption distribution with histogram of each year. Now let's go ahead and see this power histogram for each of these variables. All right, and to do that, what I can do, to do that I can just simply copy this one, okay, this plot, and then after that, so this is actually for active power. All right, and here I am gonna do a histogram for full data. All right, so just copy and paste it here, and instead of just plotting this data there, I'm gonna just do a histogram, and the bin here I'm gonna set 200. All right, perfect. Now you see here the global active power is moreover it is concentrated somewhere in between 1.5 kilowatt, but the global reactive power is around somewhere 150 watts, and this voltage is highly concentrated here, and the global intensity and other things. All right, so these in these parameters we are not interested much, we are just interested into a global active power. All right, perfect. Now after this, what we are going to do, we are going to see if there is any chance into into a grouping of the data. I mean, we can see here that the distribution of these active power consumption across these years looks very similar, and the distribution is somewhere concentrated around 1.3 kilowatt. So what I'm going to do now, I am going to plot the power distribution for each month for a particular year. I mean for just 2007. Okay, so for this 2007, I'm going to plot this power consumption for each month. Okay. Each month of 2007, and for that I have already written a code. Let's go ahead and see this. So here the month is range I1 to 13, that's mean it will output 1 to 12, and then here line number 3 is setting a figure size canvas 18 cross 18, and then here we have a range, that is the month 1 to 12 total, and for 2007 str month. All right, and here we are getting active power for that particular month, and then after that we are going to get here the active power data. All right, we are going to actually plot a histogram in this line, and then we are just setting the limits of x and title. So let's go ahead and run this. Once we run this, you will see here it is highly concentrated to 1.3 kilowatt and 0.3 kilowatt. All right, so moreover with this we can say that there are two model. It could be a bi model. That's mean the power is moreover much more consumed in 0.3 kilowatt range, and it is less consumed in 1.3 kilowatt range. And apart from that, you can see here there is long tail in month of the January and the February, as well as in the March and in the November and December. But there is less tail, and the less power consumption is occurred in month of April, May, June, July and August. This is because in the time of the summer, the heating systems are not used, but in the time of the winter, heating systems are used. That is why there is the long tail, I mean long power consumptions or a peak power consumption occur in the month of winter. All right, so this is all about the exploratory data analysis. Now in the next sections we are going to start working with the active power usage predictions. All right. All right, so we have done our exploratory data analysis. Now it is time to define our problem. So our problem is active power usage prediction. So we need to predict a particular household, what will be the power usage for a particular week. So what we can actually predict overall. All right, we can predict hourly consumptions for a next day or very next hour. We can predict daily consumptions for next week or next day. We can also predict daily consumptions or hourly consumptions for a next month. We can predict monthly consumptions for the next year. So there are so many things which we can actually predict. All right, so what we are going to do, actually we are going to forecast daily consumptions for a next week. All right, so a data for a particular week, I mean the previous week, data for a previous week will be given. Like data, with the data of week 1 we can predict the power consumption of week 2. From a data of week 2 we can predict power consumption of week 3. From a data of week 3 we can predict the power consumption of week 4. So this is what we are going to do. Now the questions are, what are the methods available for prediction? So there are so many methods available for the predictions, like new methods. New methods includes these methods are really very simple and very effective sometimes, but not always. And some classical linear regression models, and some classical machine learning models like k-nearest neighbors, SVM, decision tree, random forest, gradient boosting, etc. And then we have deep learning methods like CNN, LSTM, convolutional LSTM, etc. In these lessons, we will be using LSTM to predict the power consumptions for next week. Alright, so let's go ahead and start a problem framing. What we are going to do? We are going to predict a recent, based on recent power consumptions, we are going to predict the expected power consumptions for a coming week. That's mean based on week 1, we are going to predict the power consumptions for week 2, and based on week 2, we are going to predict the power consumption of week 3. Okay, and a model this type could be very helpful within the household, and this could be also very useful to power suppliers, so that they can accordingly plan, they can plan and repair their power grid. It could also be helpful on the supply side for planning electricity demand for a specific household. All right, so let's go ahead and see our data first, which we already have, data.head. You see, so this data for a particular day, for each day from 2006 to 2010, we are only interested into global active power. All right, let's go ahead and describe this data. So now you see here, I don't think we get much information from describe, but with the tail we should get information. So with this, you can say the first day of the data is 16th of December 2006, and the last day of the data is 11th of December 2010. All right, so what we are going to do, we are going to use the data till 2009 as a training data, and the data for 2010 for a testing. All right, which we can say simply a data 2010. So the data for this particular year, that is the 2010, we will be using this for a testing purpose. All right, and but the data for the before 2010 will be used for a training purpose. All right, so let's go ahead, first get a data train. The data train is equal to data.log, and inside that we are going to get all the rows till 2009 December month of 31st. All right, and all the columns. Now you see here a data train. Now with this, you see here 16th of December 2006 to 31st of December 2009. All right, so we have got our data train. Now after that, I'm gonna get testing set. Okay, so for a testing set, I can say the data test is equal to data and then just 2010. All right, so here you see the data test dot head, and in this we have got all the data of testing set, and similarly we have got a training set as well. But as I told you earlier that we are not interested into the other set of the data. So for that, what we can do, actually we can just take this particular global active power of the data that we can get from here as well. All right, so with this we have just global active power of the data. All right, so the very first column, and similarly we can get that data from here as well. Instead of getting all the rows, all the columns, we can just get a first column. All right, sorry, that should be the one, is it? No. Okay. All right, so with this I have got a global active power. All right, so with this now you can notice that I have a data training set and the testing set. So let's go ahead and get the shape of these data. So the data dot train then dot shape, its a shape is here 1100 1112, and similarly data underscore test dot shape, here we have 345. All right, so we have got our training and the testing set. Now we need to prepare our the testing data. All right, so let's go ahead and write here prepare, sorry, the training data. The first, prepare training data. How we are going to prepare our training data? For example, let's say we have here, the data train, dot head, the first 10 days of the data. So what we are going to do, we are going to take this week of the data, I mean the first 7 days, 1 2 3 4 5 6 7. All right, so based on this 7 days of the data, we are going to put the next 7 days of the data. Let's go ahead and take it 14. All right, so the first 7 days of the data will be into a input vector, and the next 7 days of the data will be into output vector, that is the y. And then I'll leave this 1 day, and then again I'll collect next 7 days of the data, and then finally based on those next 7 days of data, I'll be predicting another next 7 days of the data. All right, perfect. So based on this, let's go ahead, first convert this data train into a numpy array. Data train is equal to np dot array. Then here we have data train. All right, with this I'm gonna prepare x train, and then y underscore train is equal to, there are two empty list. Once I'm done with this, then definitely you would understand. Allow me some time. So the for I, all right, in range of, what I'm going to do here, I'm going to start from the 7 days. All right, so 1 2 3 4 5 6 7. All right, so I'm going to start from here. Okay, so the range 7, and then length of this whole data. All right, so that I can say like length. All right, so the length of data underscore train, then -7, because this -7 we will be putting this 7 into a training y train, I mean into a output. All right, so with this we get x underscore train dot append, and then here we have data underscore train. All right, so with this I minus 7. Now you see I started with the 7, but I minus 7, that's mean the 0. I had started the loop from here. Now the I minus 7, I mean the loop will start from here till I, and that I is 7. All right, here that is I. So with this I'll first get these first 7, and then another 7, and then another 7, and similarly I'll be getting into X train. Now after this I'll be getting into Y train as well. So that I can say the Y train dot append, and similarly I should be getting the data of next 7 days, and that starts from here 1 2 3 4 5 6 7. Yeah, so these next 7 days of the data, and that starts from the data underscore train, and that starts with I, and then I plus 7. All right, so with this we have the data of Y train and the X train. So let's go ahead and convert this into a numpy array before we check it into its shape. Y underscore train is equal to np dot array. Here we have x underscore train, and then here we have np dot array y underscore train. All right, so let's go ahead and check it. X underscore train shape. Yeah, so this says that we have total 1098 rows and the 7 column, and similarly we have for y train as well. All right, so let's go ahead and check it with the pandas data frame. That we can do simply with pd dot data frame x underscore train. So with this, now you see here, these are the 7 days of the data. So here the first 7 days of the data you see here, okay, 1209, and these are the first 7 days of the data. And then in the another row there is next 7 days of the data. All right, so you see here in the another row, next 7 days of the data started from 3390 to this one is 4773. All right, and similarly in the third row you see it starts from here 2203 to 2550. All right, so this is how it is working. And similarly, if you see the y train, in the same way you will get here very next day. All right, so the first 7 days of the data is here, okay. These are the first 7 days of the data, and then here we have next 7 days of the data. So based on these first 7 days of the data, we are going to predict a next 7 days of the data, that is here. All right, so this is how we do the multi-step prediction using RNN and LSTM. So the data preparation is really very important. So this is how we have prepared our training data set. All right, so once the training data set is prepared, now one thing you can notice here is that this data scaling is too high, and the neural network expect the data set in between 0 and the 1. That's when we are going to apply here a scaler. Okay, so we are going to apply here a scaler, and that scaler, first I'm going to apply here x scaler for this x variable. Okay, so here we have x scalar is equal to min max scalar, and then here we have x underscore train is equal to x underscore scalar dot fit transform x underscore train. All right, and similarly we need to create here y scalar. Y scalar is equal to the min max scalar, and then here we have y underscore train is equal to y scalar dot fit underscore transform, and then here we have y underscore train. So with this we have got a scaled version of x train and y train. All right, we can check that, just copy it and paste it here. So that is a scaled version, all the values are in between 0 and 1, and similarly we can see for x train as well. All right, and now let's go ahead and see the shape of x train. And once we see the shape of x train is 1098 into 7, but the neural network LSTM expects a 3-dimensional shape. So what we need to do, we need to reshape our x variable. All right, so that we can do x train is equal to x underscore train dot reshape, and that reshape is 1098 into 7 and 1. All right, so with this we have reshaped 2-dimensional array into a 3-dimensional array. All right, so now we are ready to build our LSTM model. All right, so LSTM model building is really very simple. I have already covered how you can build LSTM model in my previous videos. You can go ahead at my channel and watch those videos. But in any way, I'm gonna prepare this LSTM model. This is really very simple. I'm going to first, as you remember, earlier we had imported here sequential layer and other layers from a TensorFlow. All right, so we had here a sequential and LSTM and the dense layer. So that is what we are going to need here. All right. Since this is regressor problem, instead of calling it model, I'm going to call it regressor. Instead of regressor, I'm just calling it reg. The reg is equal to sequential, and then I'm going to add here the first LSTM layer. Okay, and if you press shift and the double tab, you will see here a detailed documentation of this LSTM layers. Okay, so in the very first, it takes inputs, units, activation functions, and input shape. So these are the necessary input parameters which it takes. So in the very first layer of LSTM, I'm going to say that it should have a 200 units. And then the activation functions, I'm going to pass as ReLU activation function. And then input shape for this, I'm going to say that it should have 7 cross 1. That is a 7 you see here. This is a time step. Input shape should be given into a time step and the number of features. Since we are taking just a single features and there are 7 time steps, that is why we are passing here 7 at 1. And once it is done, then I can just say here reg dot add, and I'm going to add here a dense layer. All right. As usual, if you remember my in previous videos in regression problem on a single step model prediction, I had added just a single units of a dense layer. But this is multi-step problem, multi-step prediction, and we are predicting 7 steps ahead in the future. That is why we will be needing here 7 units of a dense layer. All right, so once it is done, our model is built. It is very simple model. Then we need to compile this model with reg.compile, and a loss function which I'm going to pass here, that is MSE, mean square error, and the optimizer which I'm going to use, that is the stochastic optimizer, that is the Adam optimizer. And once the model is compiled, we have reached into a final exciting step, that is the model training. So there we will be passing here x underscore train and then y underscore train, and we are going to train it for 100 epochs. All right, so let's go ahead and run this. It might take a little time to train it for 100 epochs. So let's go ahead and wait for some time to complete its training. All right, so the model has trained and its minimum loss is somewhere 0.23 and or 0.22 kind of. All right, so we have trained our model. Now it is time to prepare our testing data set and test this model. As you had seen here previously, I had prepared the training data set, and similarly we need to prepare our testing data set as well. All right, so let's go ahead and see our test data set. So the data.test, this is a series. All right, we need to convert it into a numpy array. So that is the np.array and then data underscore test. So with this we had converted the test data into a numpy array. All right, and as we prepared our the training and the testing data set, similarly we are going to prepare our this training data set. Similarly we are going to prepare our test data set as well. So what I can do, I can just copy it and then I can paste it here. And you see here, instead of x train, I need to give it x test, and then here the y test. All right, instead of this the data train, I need to replace it with the data test. All right, and similarly this x train should be replaced with x test and y test. All right, let's go ahead and run this. So once we run this, we have got X test and Y test. Alright, so let's go ahead and convert these X test and the Y test list into a NumPy array. That we can do with X underscore test, Y underscore test is equal to NP dot array X underscore the test, and then NP dot array Y underscore test. Alright, so we have got here training and the testing data set. Now we need to scale it. Okay, as you see here, X test data set is not scaled down in between 0 and 1. That's mean we need to scale it down. So let's go ahead and scale it. X test is equal to X underscore scalar dot transform. Since we have already done fit transform in our training data set, we don't need to do here fit transform again, otherwise data will overfit, model will overfit actually. So here we have X test, and similarly we have Y test is equal to Y underscore scalar dot transform Y underscore test. So we have got our test data set in between 0 and 1. There are some values also in negative, okay, because of the scaling. All right, after this, what we need to do here, after this we need to reshape the test data into a 3 dimension. You see here it is currently into a 2 dimension, so we need to reshape it. X test is equal to X underscore test dot reshape 331 and cross 7 cross 1. Now the 2-dimensional data has become a 3-dimensional data. All right, so the shaping etc is done. Now we are ready to do prediction. So let's go ahead and do a prediction. So here we can do Y underscore pred is equal to reg dot predict X underscore test. All right, so we have got Y predicted. Now you see here Y pred, its values are in between 0 and 1. We need to do inverse transformation to bring it into a original value. So let's go ahead and do a inverse transform. Y pred is equal to Y underscore scalar dot inverse transform Y underscore pred. So with this we have got this Y pred into original value. All right, and similarly we need to bring this Y test into original value as well. So let's go ahead and say it Y true is equal to Y underscore scalar dot inverse transform and then Y underscore test. So with this Y true is also into original form. All right, now what we need to do, we need to evaluate our model, and for evaluation we can do it with the root mean square technique. All right, RMSE. So let's go ahead and type here evaluate the model. The one thing you might notice here is that our prediction is done. We have the true value. Now we don't have any other way to check how accurate our model is. All right, like in a classification we get accuracy during the training, but in the regression problem we don't get accuracy. We compare the performance of a regression model by seeing its root mean square error, so RMSE. So for RMSE I have already written a function for RMSE. I'm just gonna copy that function and I'll explain you. Okay, so here for this RMSE we have model, okay, evaluate model of a function in which I'll pass Y true and the Y predicted value, that is the Y pred. And after that for each of the rows, okay, for each of the Y pred rows we will be calculating, each of the columns. Each of columns are representing that the prediction for each day. So we'll be calculating that here. All right, RMSE for each day. like Monday, Tuesday, Wednesday, Thursday, etc. And after that we will be doing I mean, in this another one I'll be doing RMSE score for a whole prediction, I mean for each of these values. So I'll be comparing each of these y true values and y predicted values, and then we'll be calculating their RMSE. You see here mean squared error, and then there is a square root, so it becomes RMSE, root mean squared error. Okay, and that is being stored into a score list. And after that, here in this I am calculating RMSE for whole prediction instead of this day by day prediction. And once it is done, then I am getting here average total score. That means I am dividing here by a total number of predictions. And how you can get the total number of predictions? In a matrix, rows into a column says that the total number of elements presents into a matrix. Once we run this, it returns the total score, that's mean total RMSE for each of these predictions, and a score for predictions of each day separately. All right, let's go ahead and call this evaluate model. Once we call this evaluate model, we pass here y true, and then we pass here y pred as well. Let's go ahead and see how much error we are getting. So in this we are getting root mean square error around 598 watts. All right, so this is the watt root mean square error for each predictions. This is a you can say average error. Now the question is, how would you make sure that your model is performing well? A global standard is standard deviation of your predicted model. Okay, I mean standard deviation of a true values. So np.std y underscore true for the first rows. All right, first column. Let's go ahead and see. The first column says that standard deviation, it has a 710. That means we have made a very good model, actually very good prediction. If your model prediction accuracy or the error is less than the standard deviation, you can say that your model is actually good, because this standard deviation is standard error in your the data, but your model is predicting with just a error of less than the standard deviation, which is 710. All right, so this is all about in this lesson. Thank you so much for watching this video. Please do not forget to like and subscribe this channel. If you have any doubts, please comment below, and if you want any other lesson on any other new topics, you can just comment below and let me know. Definitely I'll try to make that lesson. Bye bye, have a nice day.